integration by substitution, U sub, with inverse trig functions. Let u equal f of x, that is a function of x, and a be a number. Then the integral of du over root a squared minus u squared is the arcsine of u over a plus c. The integral of du over a squared plus u squared is 1 over a arctan of u over a plus c. Notice the extra 1 over a here. And the integral of du over u times root u squared minus a squared is 1 over a times the arcsecant of u over a. I'm only going to do these 3 inverse trig functions. You should be familiar with basic arcsine, arctan, and arcsecant. But now we're going to do some u sub with these problems. Let's start by doing the integral of dx over root 9 minus 4x squared. You need to recognize that this is going to be some sort of arcsine. It's the form of arcsine. Where in this case we say a is 3 because a is a number and that's a squared. And then u is 2x because we have minus u squared. So this is going to be the u sub that we do. U equals 2x, giving us u equals 2 dx. We're off by a constant multiple of 2, so we can multiply by a 2 so that we have the full du, and then a half on the outside to fix it. And now this is going to give us 1/2 the integral of du over root a squared minus u squared, which is that extra 1/2 just from the fix of the u sub times what? Times the arcsine of u over a, plus c, of course. And then we can substitute in our u, so with 1/2 the arcsine of 2x, and we can substitute in our a, 3, giving us the arcsine of 2x over 3, and then plus c. Our next example is going to be an arctan, and you have to recognize this as arctan. In fact, let's put kind of the full thing here. 1 over a arctan of u over a, then plus c. I know it's of this form. The 2 is a squared, so a is the square root of 2. The 16x squared is u squared, so u will be 4x. Now let's do the u sub. Du is 4 dx. We need a 4 to fix it, and a 1/4 on the outside as well, giving us 1/4 the integral of du over a squared plus u squared, which is 1/4 times, now with arctan we have that extra 1 over a, so 1 over root 2, and then the arctan of u over a, plus our constant of integration. And I'll leave it just like that. One more that we need to recognize as an arcsecant. So my form should end up being 1 over a times the arcsecant of u over a plus c. So our a is 3 because a squared is 9. And then our u is x because u squared is x squared. So I don't really need to do a u sub, but I'll go through the process anyways because du is dx. And this would end up being what? Well, it's going to end up being, and I'll pull the 3 outside here, I'm going to have du over u times u squared minus a squared, which is 3 times 1 over a, so 1 over 3, and the arcsecant of u over a plus c.